whenever you need to pass your state card test. This is the inverse square law version right here that I think is the easiest one. If you notice, you got 4 variables: intensity 1, intensity 2, distance 2 squared, distance 1 squared. All you gotta do is remember, you write it out like this, and then every single question is gonna have 3 out of 4 of these in the question. It only leaves one that you gotta figure out how to solve. I also want to point out that intensity 1 and distance 1 go together. Intensity 2 and distance 2 go together. You'll notice that they're flip-flopped. Intensity 1 is on top, intensity 2 is on the bottom, distance 2 is on the top, distance 1 is on the bottom. All you gotta do is remember this. Just remember this. Take a picture with your mind. Now we're gonna go over it a bunch. Basically, the idea is you get a question like this. We have an iridium source. We're picking up a dose rate of 18 MR at 65 feet. What would the dose rate be at 90 feet? If you notice, I highlighted 1, 2, 3. There's always 3, always. Okay? All you gotta do is take these and fill them in. Intensity is your MR per hour, distance is your feet. So the first one we see is intensity of 18 MR. So intensity 1, intensity 1 is 18 at 65 feet. Remember, these two go together. Distance 1, 65 feet. Okay? Over here, what would be the dose rate at 90 feet? Intensity, we don't know. What do we know it's at 90 feet? Okay? Everything that we need is here except for this. So we just take this exact formula, intensity 1 over intensity 2 equals distance 2 over distance 1 each squared. We just change these. So intensity 1 is going to be 18 over intensity 2. I don't like to put the question mark, and you'll see why. Distance 2 is 90. Squared over distance 1, which is 65 squared. Okay, now we've got 18 over intensity 2 equals 90 squared divided by 65 squared. Okay, so let's just simplify these. Grab the calculator. 90 squared x2 right here, this is squared, 8100. Just remember, squared means 65 times 65, that's all it is. So you can also do it that way. 65, 65, 4225. Okay, so that cancels all this out. So that leaves 18 over intensity 2 equals 8100 divided by 4225. First thing we can do is simplify that. Just what it says. 8100 divided by 4225 equals 1.9. Don't need all the rest of this. Okay, so we can rewrite it now, make it a little cleaner looking. 18 over intensity 2 equals 0.9. Okay, now, again, we got to get this intensity 2 by itself. Looks kind of weird. Okay, so this says 18 divided by intensity 2 equals 1.9. We need to get rid of this 18 so we can get the 1.2 by itself. But whenever you have a fraction set up like this, you can only really do anything with the bottom part. Okay, so since this says 18 divided by 1.2, we're just going to take times 1.2 on both sides of the equal sign. When we do that, these cancel each other out, which just leaves 18 equals 1.9 times by I2. That's all that's left. Okay? We still don't have I2 by itself, but it's got to be by itself. So in order to get rid of this 1.9 so we can get this by itself, we just divide by 1.9. Since this is 1.9 times I2, we just always do the opposite of whatever it says to get rid of it. Okay, so these cancel each other out. And that leaves 1.8 divided by 1.9. I'm sorry, 18 divided by 1.9, which is going to be 9.5. Just to make it simple. So now we got I2 by itself equals 9.5. We know that I2 is intensity, so the answer is going to be 9.5 MR per hour. They like to throw these in here where they'll give you a question that says, an answer, in the test says 9.5 MR. It's going to be maybe A, and then B is going to be 9.5 MR per hour. Don't forget about per hour. This is a dose rate question, okay? There's another one. We're using an iridium source and we're picking up a dose rate of 25 MR per hour at 58 feet. At what distance would we set up our 2 MR boundary? Okay, so first thing, 25 feet at 28 intensity, 25 MR. God. Okay, so the first thing we're going to see here is 25. I1 is 25. Whoa. D1 is 58 feet. At what distance would we set up our 2 MR boundary? 52. Distance 2. Unknown. Okay. So, intensity 1. 25 over 2 equals D2 is unknown. We're just going to leave it D2 squared over 58 squared. Okay, so again, this right here says 25 divided by 2 equals D2 squared divided by 58 squared. So the two things we can do right away is divide this by 2. 25 divided by 2, 12.5 equals D2 squared. Nothing we can do with that. Over 58 squared. 58 x2, 3364. Now, we've got 12.5 equals D2 squared over 3364. Or you could say D2 squared divided by 3364. We still need to get this D2 completely by itself, so we got to get rid of this. If it's divided by 3364, we just take times 3364, both sides. This cancels itself out. This one here is just going to do the calculation. 3364 times 12.5 equals 42,050. So now we've got 42,050 equals, all that's left on this side is d2 squared. So we still don't have just d2 by itself. So in order to get just d2 by itself, we got to get rid of this little 2 right here. The only way we're going to be able to do that is just do this. Square both sides. Square root both sides, okay? That, whoops. This eliminates this. And we just got to hit 4205. And then this little 2 over the square root symbol equals 205. So we get 205. So distance 2 is going to be 205 feet. Since it's distance, it's feet. Don't forget to put feet. Otherwise, they'll put 205 MR per hour maybe on the test and screw you all up. Let's do one more. I think I got one more. If you're using an iridium 192 source with 52 curies, at what distance is your 2 MR boundary? We've all seen this one. How do you find your 2 MR boundary with 54 curies? But let me show you how to do it using the same system. Okay, we know we have 54 curies. Okay, so we know intensity 1. We're going to have to figure out 54 curies times our dose rate constant, which is 5,200 feet, 5,200 MR per hour at 1 foot, which means 5,200 MR per hour at 1 foot, that our distance 1 is 1 foot. Okay? Now, at what distance is your 2 MR boundary? So we know intensity 2 is 2. We don't know what our number of distance is. That's what we got. Okay? So again, 54 curies times 5,200 MR per hour. So we got intensity 1 over 2 equals unknown over 1. Something I want to see if you remember from math is that anytime you have anything that's divided by 1, it is automatically just what it is. It's just 1. The 1 just is nothing. Okay? It's just a placeholder. So now we've got d2 squared equals 54 times 5,200 divided by 2. We know we can solve this pretty easily just by going 54 times 5,200 equals 280,800. It's also divided by 2. So might as well just divide it by 2 while we're here. The answer is 140,400. Okay, I read that wrong. Zero here. Okay, equals 2 squared. If you remember from the last one, all we got to do to get rid of this little exponent right here is take its square root. Get rid of this one, which is, we've already got it pulled up here. We just hit the little square button right here. 374.69, so let's call it 374.7. Distance 2, so that's going to be feet. Distance 2, your 2 MR boundary with 54 curies, 374.7 feet. The way we can check that is same way we always do our 2 MR boundary, which is 5200 times Curies, which is 54, equals this, divided by 2, is this, squared, 374.7. So we know this is our 2 MR boundary, okay? And I got one more. We're picking up 28 MR at 71 feet. How many Curies do you have? Okay, we know we have 28 MR. At 71 feet. How many Curies do we have? So the problem is I can't figure out my Curies if I set it up this way, because I know my Curies are going to be intensity 1. It's always going to be intensity 1 where you get your Curies. So we're going to have to rethink this. Picking up 28 MR at 71 feet, that means this is 21 MR, 71 feet. We know we need to figure out what our Curies are. Times 5200. At 1 foot. Okay? I'm just trying to figure out the Curies. We know how these work. So intensity 1 is going to be, let's put Curies times 5200 equals 21 equals 71 squared. D1 squared. I'm sorry, over 1. D1 is 1. 1 squared is just 1. So really, we can just get rid of this. Okay? Now what are we going to do? This is where it gets crazy, right? We've got to get rid of this 21. So, simply enough, we just do, whoops, let's get rid of 21 by 1. 21 times 21 from both sides. So now we've got Curies times 5200 equals, what's 71 squared? 71 squared, 5041. 21, which also equals 5041 times 21, 105,861, 105,861. Okay, now if you notice here, we have times 5200 on this side. We need to get rid of this, so let's just go divide it by 5200. Both sides. That, which just means our Curies is going to equal whatever this is. 105,861 divided by 5200. It's already up there, so let's go divide it by 5200 equals 20.35, so let's call it 20.4. Curies. So, if you're picking up 28 MR at 71 feet, you have 220.4 Curies. That's it. Okay? Sound good? Awesome.